day 3 of our word problems involving sine and cosine. We have 3 problems to try right now. At any time it goes too fast, or I ask you to, please press the pause button on your video. Okay, this first one here, if you read through it, go ahead and take a second, pause the video if you need to, read through it. We have a buoy. It bobs up and down a total of 6 feet from the top of a wave that's 3 feet above sea level, completes a full cycle of bobbing up and down every 12 seconds. First thing it wants us to do is sketch the equation of the above situation. Before we do that, I think we should need the equation and take a look at the amplitude, period, and our scale before we're ready to go ahead and graph it. So the first question, part A down here, asks, what function should you use? We'll go back. It says from the top of a wave, 3 feet above sea level. So if we're deciding between sine and cosine, we always know that sine starts at 0. So if we're starting at 3 feet above, we know we want to use the cosine graph. All right, so we're going to use the cosine graph here. And our reason is, again, it starts at 3 feet, not 0. If we were just starting at 0, maybe the sine curve would be a better option for us. What's our amplitude? And if you remember the equation we've been using all unit long, 1/2 the absolute value of my maximum minus my minimum. Now those are not given easily as some of the problems we've done over the last 2 days. You will see from the top of a wave 3 feet above sea level. So that's going to be my maximum. And then you go ahead and look, I also have given you that it bobs up and down a total of 6 feet. So if we're at 3 feet for the max, that must mean the min, if I'm going to travel a total of 6 feet from 3 feet down, is going to be -3. Plugging that into my amplitude formula, I'm going to end up with 1/2 3 minus a -3. And as we talked in class, remember, if the maximum and the minimum are the same number, it's going to be that number for your amplitude, which is going to be 3 here. Keep going. What's our period? We'll take a look. We don't need the formula 2 pi over frequency here. I've already told you it completes a full cycle every 12 seconds. And that's what period is. How long it takes a graph, sine or cosine, to make one full cycle, in this case, 12 seconds. So the period here is going to be 12. And now let's put everything together and write the equation. So we have y equals, our amplitude we said was 3. Cosine. Okay, remember, period is not going to go in here. This is going to be my frequency, which we have not calculated yet. All right, so up here, off to the side, let's calculate our b value, frequency. And we know we involve the period of the graph that would involve to find the frequency. Period, we just found out in part C, was 12. Equals 2 pi over b. Cross multiply. I got 12b equals 2 pi. So b is equal to pi over 6 when I reduce 2 over 12. So the equation again, y equals 3 cosine pi over 6 x. Okay, so there's my equation. Part E, our final question here. Use the equation to estimate the height of the buoy when t equals 27 seconds. Okay, I think it would be easier to see the graph before we do that. So let's set up our graph right now. Before I decide where to put my x-axis, I should probably think about what the scale is going to look like here. So we already know our period is equal to 12. So to find what the x-axis is going to go by, I'm going to take 12, multiply it by a fourth. We're going to go by 3s. And let's see, this is going to have a maximum height of 3 and a minimum height. Since the amplitude is 3, we know the minimum is going to go down to -3. So we want to at least make sure our y-axis has both -3 and 3 on it. Okay, so I'm going to go by 3s. And again, your y-axis has to go up to 3, down to -3. Okay, cosine does not start at 0. It starts at our amplitude, which is 3. And then we start hitting our zeros. We hit our minimum at 6 on the x-axis. And then start repeating itself once again. There's our curve. Now answer the question in part E, estimate the height of the buoy at 27 seconds. Well, think about this. After 12 seconds, it's going to start repeating itself again. So 3, 6, 9, 12, and then we're back to 15, 18, etc., all the way back to 24. Right here, we're going to be back to 24. So 27 would be in the same place where my 3 is. Right? Because we just keep repeating ourselves every time. 3, 6, 9, 12. If you kept going through all of them again, 27 would be in place of the 3, which we know is about 0. Right, so the height at 27 seconds is going to be about 0 feet. All right, so there is question number 1. Question number 2. I'm going to have you guys graph this on your own. The tide modeled by the following cosine equation. Graph the function from 0 to 12. Okay, so first couple things we're going to need to know is what's my scale here so I can set it up. And I don't know what the scale is unless I know what the period is. Since I had given you the equation, the frequency we can pull right off the equation is pi over 6. I've had a lot of practice in this. 2 pi times 6 over pi. So the period here should be 12, meaning scale should be 12 times 1/4, or 3. So we're going by 3s again. Just be careful when you set up your y-axis. Take a look at your max and your min value here. Your y-axis here, let's see, it should be going up to 2 for the amplitude plus another 8 for that vertical shift. So it should go up to 10 on the y-axis. And for your minimum, the amplitude said, all right, it's going to go down to -2, but after shifting the graph up 8, I should have a minimum value of 6. So your graph should go, at least have a y-axis with 6 to 10 on it, and you're going by 3s for 1 full cycle. Okay. You can do that, pause the video right now, go ahead and set up your graph, and then restart the video so we can do part B, which involves using your graphing calculator. Okay, for part B, we're going to get our graphing calculator out, determine when the tide is at least 7 feet, and that's going to be kind of hard to tell just based off your graph. So we're going to have the calculator help us out here like we did a couple days ago. So the first thing we need is making sure we type in the correct equation into y1, which is our -2 cosine. Use your alpha y equals app. Pi over 6 x plus 8. Okay, a couple things here we want to make sure of before we press the graph button. First thing is you can't see any sine or cosine graph unless you're in radian mode. So let's make sure we're in radian mode. And we want to make sure we're in the proper scale, proper window size. So go ahead and hit your window button. We know we're going to go from, it looks like on the x-axis, from 0 to 12, because that was the period. So 0 to 12. And on the y scale, I don't know what you guys went by, but we know we got to at least go up to 10. So I'm going to go 0 to 10 on the y scale. And then we can graph. So that's our original curve. That should look like what you had graphed in part A from 0 to 12. Now what we want to find is when is the tide at least 7 feet. So we're going to go back to our y equals screen and say, hey, could you also show us where it's at 7? So we're going to have graph so that you can see there's 2 places. I want to know in between what's the minimum and what's the maximum there. So what we're going to do is go back to second trace, our calculate button, intersect 5. And you want to put that little blinking star there, the little X, on one of the points of intersection. close as you can come. It'll say first curve, you hit your enter button. It'll say second curve at the bottom, hit enter again. And then your guess, enter a third time. And you'll see x is equal to 2. So from 2 to, what's the other point? We need to find what this point is right here. 2 to what? So again, same process, second trace, intersect, and bring that bad boy right over to the right side now. So you land as close as possible on it. And then same thing, enter 3 times. And you'll see it comes up with 10. So from 2 to 10, the tide was at least 7 feet. So we go back to the question here. It says write your answer as an inequality. So we said from 2 to 10, what if we want to write this property as an inequality? So the brackets, parentheses aren't going to cut it here. From 2 to 10, our tide was at least 7 feet. And we want the or equals there. We want the or equals there just to make sure. Because at 2, if you saw at 2, it was equal to 7. At 10, it was equal to 7. All right, so that's why the or equals are there. Because at 2, it was equal to 7 feet. At 10, it was equal to 7 feet. And again, we're looking at for at least. We want to include those two values. Okay, what I need you guys to do now is try on your own number 3. Okay, it is a little bit more of a reading question, a little bit more difficult, but I think you guys can handle it working together. And then make sure you download the class notes to make sure you have the correct copy. Thank you guys for putting up with this.